So today we are going to be doing 7.7, which is problem solving. So it's basically taking everything that we've learned in topic 7 and applying it to different problems. Okay, so my learner's question is, how can I use functions to help me analyze situations, draw conclusions, or make predictions? Okay. So, example number 1 says a model rocket rises quickly and then slows to a stop as it reaches its maximum height as its fuel burns out. So when I'm saying rising quickly, I'm seeing something like that. Okay, and then slowing to a stop, something like we're getting to a stop. Okay, stop as it reaches its maximum height as its fuel burns out. It begins to fall quickly, okay, until the parachute opens, after which it falls slowly back down. So I'm going to start by falling quickly and then I'm going to go fast like that, or slow. Start by falling quickly and then fall slower. So we're going to use the tiles over here to sketch a graph of the height of the rocket during its flight. Label each section. Okay, so I need to start in this corner. So I only have a couple that are going to be like that. So I have this one and this one. Those are the only two that start in the corner where the height is 0. Okay, which one shows that it's rising quickly? Okay, this one does. So this is going to be my number 1. And I'm just going to look and see it goes not quite halfway. I'd say about a quarter of the way. Okay. Okay. Then I have to find a piece that has a line that goes from that point. So really, I think that's too far over. I think this is going to be my number 2. So it goes a little past halfway. Okay, it doesn't have to match up. It doesn't have to be perfect, but try your best. Okay, then I'm looking for one that starts about here, and it looks like that one's going to be and it goes all the way to the corner. So I need to make sure I go all the way to the corner. Okay, now I'm looking for something that starts in the bottom left, and I think I'm done with my model rises quickly. My model rocket rises. Okay, so now I'm getting to the point where it's going to start slowing to a stop. So that's going to be this piece and this piece. So this is going to be my number 4 piece. Okay, and it's going to come up. And it's going to start to slow down. Okay, and then this is going to be the other part of that. Okay, and there's where it starts to fall. So here's where it kind of came to a stop. Okay, and then it started to fall quickly. Okay, and then these 3 pieces look all the same, so it doesn't really matter which one you do because they're all the same. Okay, and you're just going to go like this. Okay, so it's just falling straight back down. Okay, so now I need to label the graph. Okay, so this part right here is the rising quickly. Okay, this part right here is where it slows to a stop. Okay, and then this is falls quickly. And then this is the point where the parachute opens. Okay. Okay, go ahead and do the you try number 1. Okay. Example number 2. Explain why y equals 2x plus 3 is a linear function using both a table and a graph. Okay, so we need to think about what needs to be true in a table and in a graph in order to have a linear function. So with a table, okay, what I'm looking for is that constant rate of change. And remember, rate of change is change in my y's divided by the change in my x. Okay? In a graph, I'm looking for a straight line. Okay, so hopefully we see that. Okay? So I'm going to start by I'm actually going to use 5 x values, and I'm just going to do -2, -1, 0, 1, and 2. Those are some good ones to use, some good starter points. And then I have my y equals 2x plus 3. So I'm going to plug in 2x plus 3, plug in this x value for this, and then solve and see what I get for y. So I have 2 times negative 2 plus 3. Well, 2 times negative 2 is negative 4, and then negative 4 plus 3 is negative 1. So I'm just going to go ahead and write that in this box. Okay. And I'm going to do the same thing for negative 1. 2 times negative 1 plus 3. Well, 2 times negative 1 is negative 2. If I add 3 to that, I get 1. Okay. I'm going to plug in 0. 2 times 0 plus 3. Well, 2 times 0 is just 0. So I'm left with just 3. Okay. 2 times 1 plus 3. Well, 2 times 1 is 2. Plus 3 gives me 5. And then 2 times 2 plus 3 gives me 4 plus 3, which equals 7. Okay, so now I have to make sure that I have a constant rate of change. Okay, so my change in my y, or my x, is always 1, just because those are the values that I picked. Okay, those were my independent variables, the ones I chose. And then from here down, I got to check that because these ones were the same, the ones on my output need to be the same. So negative 1 to 1 is a change of positive 2. 1 to 3 is a change of positive 2. 3 to 5 is positive 2, and 5 to 7 is positive 2. Okay, so there I've proven that because rate of change is constant, this is a linear function. Okay. Okay, now we move on to the graph. Now, we have to make our graph, and these are the points that I'm going to use to plot. Okay, I have negative 2, negative 1, negative 1, 1, 0, 3, 1, 5, 2, 7. So usually you'll see something that looks like this, okay, where it's nice and even. Okay, because I know that most of my y values, which is this axis right here, okay, because I know that most of my values are positive, I'm only going to include a little bit of the negative. Okay, so here's my x-axis, okay, and then my y-axis is going to be here, okay, so that gives me plenty of room to graph all of my points, okay. So first one I'm going to plot is negative 2, negative 1, and I'm just going to use a scale of 1, so here's negative 1, here's negative 2, remember your x comes first, so this is my x, forgot to label my y-axis. Okay, this is my x-axis, so this is negative 2, and then I go down negative 1 on the y-axis. So that's my first point. Okay, my second point is negative 1, 1. Okay, this time I went up because I'm at positive y's now. Okay, I'm at 0, 3. Then I'm at 1, 5. And I'm at 2, 7. Okay. So I'm going to draw a nice line through there, okay, and right there I've proven that it's a linear function because it's a straight line, okay, so because it's a straight line, it's a linear function. All right, go ahead and do the U-try.